In this problem, we need to solve the equation log to the base 6 of x plus 4 minus log to the base 6 of x minus 1 equals 2. What type of equation do we have here? It's an equation that has two logarithmic terms, but it also has a constant. So we need to review the steps for solving logarithmic equations in which every term is not a logarithm, because we had that one constant there. So step 1 says move all the logarithmic terms to one side of the equation and all the other terms to the other side. Let's check our equation. Both our logarithms were already on the left-hand side. Our constant was on the right-hand side. So step 1 was already done for us. Next, we have to combine all the logarithmic terms into a single logarithm, then convert to exponential form, solve for the variable, and don't forget to check for extraneous solutions. So in this case, I need to combine these two logarithms. And in order to do that, I'm going to use the quotient property because one of my logarithms is positive and one is negative. So I have this case here where I have log to the base b of m minus log to the base b of n. When I combine them into a quotient, the logarithm that was positive, its argument goes in the numerator. The logarithm that was negative, its argument goes in the denominator. So in our case, I'm going to have log to the base 6 of a quotient. The first term had a plus in front of the log, so the x plus 4 has to go in the numerator. My second log was a negative, so its argument x minus 1 has to go into the denominator. So I get log to the base 6 of x plus 4 divided by x minus 1 equals 2. So now I've combined both of my logarithms on the left-hand side. Notice the coefficient of the log term is a 1, so now I'm ready to convert it into exponential form. So the base of the log is the base of the exponent, so I'm going to get 6 raised to the second power equals my quotient of x plus 4 divided by x minus 1. So I've gone from a logarithmic equation to a rational equation. Well, 6 squared is 36 equals x plus 4 divided by x minus 1. And I'm going to multiply both sides of my rational equation by the LCD. There's only one denominator, so my least common denominator is just x minus 1. And since I multiply the right-hand side by x minus 1, I have to do the same on the left-hand side. And then on the left-hand side, distribute in the 36. So 36 times x is 36x, minus 36 times 1 is 36, equals my x minus 1's reduce on the right-hand side, and I just get x plus 4. So now I have a linear equation in x, so I'm going to collect my x's on the left-hand side by subtracting x from both sides. I'm also going to add 36 to both sides. So I get 36x minus x is 35x, excuse my bad handwriting, equals 4 plus 36 is 40. Last step, divide both sides by 35. So I get x equals 40 and 35 are both divisible by 5. 5 goes into 48 times. 5 goes into 35 7 times. So it looks like my solution is x equals 8/7. And yes, the answer can be a fraction. But I'm not done yet. I must check my answer to see if it's extraneous or not. That means plug my solution into the original equation. All I have to do is make sure the arguments of each of the logs are positive numbers. So log to the base 6 of x plus 4, so that's 8/7 plus 4. Two positive numbers added together, definitely positive. Keep going. Minus log to the base 6 of 8/7 minus 1. Is 8/7 minus 1 positive? Yes, it is. And if you're unsure, remember 8/7, if you divide 7 into 8, you get 1 with the remainder of 1. So it's 1 and 1/7. 1 and 1/7 minus 1 is definitely a positive number. So we now know our answer is not extraneous, so the solution is x equals 8/7.